Okay, this is the STEM podcast for Chapter 2, Section 3, which is the last section. This section concentrates on water and solutions. And so for water, make sure you know it's one of the most important components found in living things. And there are 6 unique properties that water has that we're going to go through each one. Number 1 is polarity. So we're going to define what makes a molecule or polar. Property number 2 is hydrogen bonding. So far we've only covered covalent bonding and ionic bonding. Now we're going to learn what hydrogen bonding is. A third property is cohesion and adhesion. Number 4, surface tension. Number 5, temperature moderation. And number 6, density. So the first one we're going to do is polarity. Water is considered to be polar due to an uneven distribution of charge. Water is covalently bonded. The hydrogens and the oxygens have a covalent bond. They are sharing their electrons. However, the electrons are not shared equally. Oxygen wants the electrons more than the hydrogen does. So it pulls the electrons more toward its nucleus, resulting in a polar molecule. When that does that, oxygen ends up having more of a negative charge, and the hydrogens end up having more of a positive charge. So the electrons in a water molecule are shared unevenly between hydrogen and oxygen. Due to this polarity of water, it makes it effective at dissolving other polar substances. So water can dissolve sugars, ionic compounds, and some proteins. The basic rule to remember is that like dissolves like. Polar solutions will dissolve polar substances, and nonpolar solutions will dissolve nonpolar substances. A nonpolar solution is a solution where they are sharing those electrons equally, not like a polar molecule. So what happens in water is that a hydrogen bond can form. So first, before we get into that, here are all the water molecules. Okay, here's your oxygen and here's your 2 hydrogens for each one. But because oxygen is more electronegative, it wants those electrons more than the hydrogens. Oxygen ends up having a partial negative charge. That's what that little Greek symbol means. And the hydrogens have a more partial positive charge. So the hydrogens end up with a partial positive charge because oxygen's pulling more of the negativity toward its nucleus, and the oxygen ends up with a partial negative charge. So if every water molecule has this, if they're oriented the correct way, these partial negative charges on oxygen will be attracted to the positive charges on a different water molecule from the hydrogen. So these pluses and minuses attract. And so this water molecule is attracted to this water molecule due to the polarity of the molecule. So all of these little dashed lines represent a hydrogen bond. A hydrogen bond is the force of attraction between a hydrogen molecule, right here, with a partial positive charge, and another atom or molecule with a partial negative charge. For example, another water molecule. So that is a hydrogen bond. Through hydrogen bonding and polarity, we get cohesion and adhesion. Cohesion is an attractive force that holds molecules of a single substance together, such as water molecules. So water's attracted to water is cohesion, where adhesion is like water being attracted to something else. Adhesion is the attractive force between 2 particles of different substances, such as water being attracted to glass. Okay, we're going to watch a clip. Sorry about the delay.
Cohesion is a force that causes liquid molecules to be attracted to themselves. This causes splashes to form droplets. Adhesion is the attraction of a liquid to a surface, such as how water spreads out on glass. The water molecules in a droplet of water are attracted to glass by adhesion, and they spread out. A meniscus is an example of a situation when adhesion and cohesion are competing. When adhesion is stronger than cohesion, a positive meniscus occurs, such as with water in a graduated cylinder. When cohesion is stronger than adhesion, there is a negative meniscus, such as mercury in a graduated cylinder.
Okay, don't worry about the whole mercury in the graduated cylinder, but notice the other one. Water in a glass test tube, for example, the water is going to cling to the glass, and that's why you get this curvature inside the glass. Okay, the next property of water is surface tension. Surface tension is caused by cohesion. The cohesion of water causes the molecules at the surface of the water to be pulled downward into the liquid. As a result, water acts as if it has skin on the surface, and it allows small insects or lizards, actually, to be able to walk across the water. So we're going to watch a clip for the Jesus Christ lizard.
Some young Costa Rican basilisk lizards are looking for food. Basilisks have been nicknamed the Jesus Christ lizard. Why? This adult male, probably the father of the young lizards, can't tell us. Nor can this female, exclusive property of the territorial male. It has nothing to do with the feeding habits of the basilisk, which consists primarily of insects and berries. This predatory reptile will help reveal the secret as it stalks the young basilisk.
This is real.
The basilisk is called the Jesus Christ lizard because it can walk, well, maybe run on water. It bicycles its hind legs, and the tail becomes a counterweight. We can't know what the snake is thinking. Did it really want to eat the lizard, or did it just want to show?
And that finishes that. Okay. Sorry about this. Okay. Oh, it's not working. All right, we're almost done. The next one is hydrogen bonding is temperature moderation. Water has the ability to absorb a relative large amount of energy as heat and the ability to cool surfaces through evaporation, which explains why we cool down when we sweat. Another property of water is the density. Solid water is less dense than liquid water due to the shape of the water molecule and the hydrogen bonding. Ice then floats on top of the water. It does not sink to the bottom. And the last part are three terms, make sure you understand. A solution consists of a solute dissolved in a solvent. Make sure you know that the solute is the sugar, the red powder sugar. The solvent is the water, which water is a really good solvent. And the mixture of those two makes up the solution, which is the Kool-Aid. And that finishes section 3, chapter 2.